Alright, in this section I'm going to go through the mFiles and some of the quick bits on how to use some commands and some functions now. First and foremost, if you need a help, I informed you about the help feature, which is really nice. Just typing in help isn't so useful because it gives you a long list of things you can check through, and it's a little unwieldy. You can click on these to get some information on help topics in this and so forth, but not the greatest. The help command is great for a specific function. Again, you can say help sign and it'll bring up help sign. Again, argument in radians is a function in elements, so forth. So this kind of gives you a breakdown of how this works. You can also hit just F1 key and you'll get the documentation like any other Windows software. And ooh, I have confidential pre-release documentation. I better close this. Ooh, no, don't look at it. Okay, good. So I did not break any violations because I did not show any violating thingies there. So, well, regardless. So this is the interface. Importantly, though, the help section will have a lot of data and things you can use to look at it. So, with all that said, importantly for all of your work, all your files, you can do calculations within the command window here. I can say 5 plus 5. I could say the sine of 5. I could say pi. Now note, pi is different here than it is in Excel. If I type in pi, I get this answer equals 3.1416. That looks a little disappointing, right? Because it looks like it's not very extensive. Remember when pi in Excel was parentheses, now you can do that as well, but you don't need to. You can just type in the pi. However, if you type in help pi again, you'll get a much longer list of what actually pi is referencing within MATLAB, and you'll notice it has a slightly more higher precision than in Excel, but it's not by much. So this just gives you a sense of how that's working. But everything we do here is not going to be saved. If you save anything here, if you try to go to the save option, switch windows, you can try to say save or save workspace here. That is just going to save the variables you have here. That's very useful if, for example, you are working on a large data set of raw data that you're editing and visualizing. You may want to just save that. Examples that come to mind is if you're doing molecular simulations and you have a data set of where all the molecules moved or how they moved in the past period of time. You'd want to save that. You don't want to lose that. But everything you do here, you will lose. None of that is stored. If you want to save any of your calculations, because calculations results aren't saved in MATLAB, only thing that's saved is the inputs. You can do that by creating a script. And we can click create a new script by going to new script. Now, it popped open in another area of my screen, but I'll bring it over here. And this is the editor window. And we saw this on Thursday, but I want to re-emphasize this because I think these are really important points and very useful background information on how to use Excel. I mean, how to use MATLAB. So first and foremost, everything you do here, every line you run in a script, if I type in 5 plus 5, it will do that as if I typed in 5 plus 5 into the script, into the command window after I run this file. If I type in a equals 4, it will do that. It will do all these things sequentially. If I do t is equal to a minus a, it will do that as well. It'll do these in sequence. So if I was to save this file, go save as, and tile it as a mFile. Now this is just a text file. There's nothing fancy about this. This is ASCII text that can be opened in any Word software. As long as it's saved as an ASCII text, it can be read as a mFile. I'm going to call this example and save. And so now, if I bring this down, and you can see my window here of where my example is, or my current folder, you'll see I now have an mFile called example. If I bring our window up, I can click run and go to our window, and you'll see in the command window it did exactly what I just said it would do. It said answer is equal to 5, a is equal to 4, t is equal to 0. You'll notice you're not actually seeing the code being entered, the line by line that we typed, but it is being calculated in the background and the answers are showing up. So that's an important point here. So now, how are we going to use this and how do we make it more functional? Just typing in code doesn't really help us, doesn't teach us much. So we have two things that we like to do oftentimes. One is we like to comment on these things. And in order for MATLAB to have a file, if I was to say my name up here, I just said Thomas Drubla, and that must be purple. I don't know why my name is purple. That's kind of cool. If I put that in there as a title of this and I save the file and I try to run it, it's going to give me an error. It says undefined function or variable called Thomas. It does not like that. I just want this to be a title. I don't want this to be a command line. So in order to call this out as something not to run, I have to put it after a %sign. MATLAB recognizes the % as don't run this. So don't run that. You want to put that in there. You want to put in CME 220 in the name of your class. You can put a date and you can put the homework name, homework number, if you're doing homework or however it looks. And then you have all of that. We have these codes, and that's great. That's a great way to do this. Additionally, you can go through and start commenting out these lines here. So I can actually on this line explain what this is if I need to. You don't always need to do this, but if it helps explain what's going on, keep things straight, and I do recommend this isn't a bad practice to do. You can explain what this is for. I can say 5 plus 5 simple math example. You can then define what A is going to be. A is going to equal to the number of apples I have. Kind of a silly thing, but sure, why not? And I can actually rechange this variable to apples. We'll talk a little bit more about that in there. And you'll notice this is kind of cool. I don't always see this. This might be a 2016 feature. Check in your versions as well. But press Shift Enter to rename 3 instances of A to apples if I wanted to. I'm not going to do that right now, but the script editor will try to keep things track and straight for you if you do make those changes. So you have apples, you have this. You can name what that is. And then I can actually also say how much apples. If I wanted to say how many apples Tim gets, I can comment that out. You can also use comments to describe things. Like, for example, if you're going to create a variable like, I don't know, viscosity, and I have viscosity is equal to 1, I can here put in this comment the units by which that viscosity value has. Notice there is no inherent method in MATLAB to handle units. That is on you to do, and the comment section is exactly where you do that. It's very important, and we'll talk later on how you can have an output with that information. But for the time being, in your mFiles, if you have a variable with units, you need to comment on it to say what units that variable is in. And then we can save this, run it, and we will get this output exactly like we would think. Now finally, the one last thing I'm going to do, and I'm going to mention, is we may not always, and I'll bring this down here, I'll show you in the command window as an example. If I say CLC, clear, which I don't think I mentioned in the previous video, CLC and clear are two extremely important variables that you want to remember. CLC just clears the command window, so it refreshes it and you have a nice blank screen to work from, and clear clears the workspace. You will often use these at the beginning or end of a lot of your mFile homework to help run it, especially if it helps keep things in order. And then finally, the one last bit of coding that you need to note and be aware of is that of the semicolon, I should say. If I just type in a new variable, and I'm going to use the rand function to give me 1,000 by 1,000 array without the semicolon, you'll see I get this really long list of numbers that's going to be created. It's going to take some time to go through, and I may not always want that to have displayed. That may be excessive. It can take time actually to run the display. It actually takes time to put that information onto the screen and let it run through. It can actually sometimes do the calculations much faster if it just suppresses it from being displayed. So I can do the exact same thing and say b is equal to rand 1000, hit with a semicolon, hit enter, and you'll notice it just instantly created it. It's here, and it didn't have to go through this long screening process of displaying all those numbers before it was done. So I encourage you, unless otherwise stated, unless it's an output that you want displayed in the command window, for every code line that you have, you will probably want to put semicolons at the end of it so it does not display that information. And only time you might want to have something displayed if it's an answer. Answer equals whatever it is. In that case, you may not want to display it because you want it to run and show in the command window. But for this purpose here, run, you'll now see the example ran. Nothing was displayed, but Apple's viscosities and our variables were created. And so I will end there, and from here on out, we're going to start talking more about the intricacies of defining variables, of defining matrix, our arrays, and start talking a little bit more about how you can actually do some more clever computations and use MATLAB to your advantage. So we'll see you in a little bit. Bye.